is AP Statistics, Thursday, March 26th. Okay, I got out the statistics free response questions from 2018. We will go, I know I assigned a couple of problems from chapter 7, I guess, on the differences in proportions, differences in means. I will go over those later. I want to move on to the actual review. I'm going to send you these questions. I don't think I gave them to you in class. If I did give them to you in class, please correct me. The first, I'm going to tonight look at number 2 and a few more, and I'm going to ask you to go through these, understand them, and also go through the questions that we don't go over. So number 2 on this test says, an environmental science teacher at a high school with a large population of students wanted to estimate the proportion of students at the school who regularly recycle. The teacher selected a random sample of students at the school to survey. Each selected student went into the teacher's office one at a time and was asked to respond yes or no. Do you regularly recycle plastic bottles? So maybe if I did this, I would ask each of you to come in and say, do you regularly recycle plastic bottles? How confident, how comfortable would you be in saying no? I really don't care about the environment. I mean, the implication there is, or the inference could be that you really don't care about the environment. You just throw your plastic bottles in the regular trash. Oh my goodness. Okay, so based on the responses, a 95% confidence interval for the proportion of all students who would respond yes to the question was calculated as 0.584 to 0.816. How many students were in the sample? Okay, how the heck are we going to do that? I mean, wow. We're just given the confidence interval. We don't know what p hat is. We don't know what the point estimate is. We do know it's 95%. We have to go back and remember what the formula is and try to somehow from that get the sample size. Maybe it's not possible, is it? Well, first thing you might want to do is write down what the formula is for the confidence interval for the sample proportion, and here it is: p hat plus or minus z star. That's our critical value from the normal distribution. Square root p hat 1 minus p hat divided by the sample size. Now, since it's 95%, you can either look up or you can remember that the z star for 95% is 1.96. So we got this. And now I played around with it, and you could, okay, so the other thing you need to realize is, well, this number, p hat plus this number and p hat minus this number, this is going to be the same number to each side of p hat, which means that p hat, the point estimate, is going to be the midpoint of the interval. That's one observation. So if we do that, we get the midpoint is 0.584 plus 0.816 divided by 2, which is 0.7. Right? That's because, of course, the confidence interval is taken as 0.584 to 0.816. So we know that our p hat, if we take the 0.816 and subtract that, we know the length of the interval on either side away from p hat, away from the 0.7, is going to be equal to 1.96 times the square root of, well, now we know that it's 0.7. 0.7 times 0.3 divided by n, and the rest of it is algebra. So 0.116 over 1.96 is equal to radical 0.21 divided by n. 0.0592 is radical 0.21 divided by n, square both sides, and you wind up getting n as 0.21 divided by 0.0035, which is equal to 60. Please follow through those steps and make sure you understand it. That's part A of this problem. Part B says, given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how the bias might affect the point estimate of the proportions of all students at the school who would respond yes to the question. I'm going to leave this. I'm not going to say very much about it. I'm going to leave it to you to think about. But I think it has something to do with the fact that the way this is set up, each student is going into the teacher's office, and there might be some factor involving that. Now the next question is, the stats teacher at the high school was concerned about the potential bias. To obtain a potentially less biased estimate, the stats teacher used an alternate method for collecting student responses. A random sample of 300 students was selected. Each student was given the following instructions. Flip a fair coin. If your coin is heads, you must respond no, regardless of whether you regularly recycle. If tails, please truthfully respond. What is the expected number of students from the sample of 300 who would be required to respond no because the coin flip resulted in heads? Well, I think you know the answer to that. The results of the sample showed that 213 of the 300 responded no. Based on the results of the sample, give a point estimate for the proportion of all students who would respond yes to the question. Okay, so you expect 150 to get a coin flip of heads, and if it's heads, you're going to respond no, and there were 213 who responded no, so that means 213 minus 150, which is 63. What is the proportion of the ones who actually could give the answer that they felt like answering? So that would be 150. So we get 63 over 150, which is 0.42. Please think about that. I wanted to go over more. Okay, so the next question is that approximately, I want you to think about how to set this up. I'm going to give you a hint. You use a tree diagram. So I'm really going to leave this one. Maybe we'll go over it tomorrow. Approximately 3.5% of all children born in a certain region are from multiple births, twins, triplets, etc. Of the children born in the region who are from multiple births, 22% are left-handed. Of the children born in the region who are from single births, 11% are left-handed. First question is, what is the probability that a randomly selected child born in the region is left-handed? What is the probability that a randomly selected child born in the region is a child from a multiple birth, given that the child selected is left-handed? So what kind of a probability problem is this? This is a conditional probability. A random sample of 20 children born in the region will be selected. What is the probability that the sample will have at least 3 children? Hint, binomial. Hint, use your calculator to calculate the binomial cumulative distribution function. So we're talking about 3, and then keep in mind, what does the cumulative distribution function do? It doesn't take the number, the PDFs from 3 through 20. It takes the PDFs from 0 to 3. So what do you have to do in order to get the the probability of at least 3 who are left-handed. Think about that. Set it up as a binomial. Use your calculator. Calculate the binomial CDF, and please work on that. So I'm going to send over to you these 5 pages for these problems. Please pull them up, print them out if you can, and start working on them. Have a good quarantine. Goodbye.